Welcome back, focus learners. Listen, today we are looking at a totally fundamental shift in how we build software. If you're tired of that endless, soul-crushing routine of copying your code, pasting it into an AI chatbot, waiting, and then manually applying the fixes yourself, well, you're absolutely in the right place. We're moving to a fully autonomous, agentic coding environment using Claude Code. This isn't just about writing better prompts anymore. It's about setting up a reliable, self-correcting workflow where an AI can actually explore, plan, and implement solutions right inside your codebase, entirely under your supervision. It's a real game changer.
Okay, let's dive into this. Here is our roadmap for the explainer. First, initializing your project environment. Second, the art of concise configs. Third, automated verification checks. And finally, independent subagent code reviews. Let's get to it. To truly master this whole shebang, we first need to define our terms. What exactly is an agentic coding environment? Basically, it's a system that actively reads your files, runs terminal commands, makes changes, and autonomously works through complex problems. You can watch it work, you can redirect it if it kind of strays off path, or, and this is the dream, you can step away entirely. Unlike a standard chatbot that just sits there waiting for your next question, Claude Code acts way more like a junior developer working directly inside your terminal. Now, it's a massive shift in how you work, but this level of autonomy definitely comes with a learning curve and operates within certain constraints that we really need to master. So, Section 1, initializing your project environment, setting the foundation with cloud.md files and hooks. Think of this initial setup as the onboarding process for your new AI developer. Doing this efficiently right up front is absolutely crucial. Seriously, without it, you're going to spend hours manually correcting basic, silly mistakes later on. On the advisory side, we have rules housed in a file called Claude.md. This is your project's team handbook. It gives Claude persistent context about your codebase so it can work efficiently from day one. We're talking bash commands, specific code style rules, testing instructions, all of that. You can even run a quick initialization command to have Claude analyze your codebase and just generate a starter file for you. But then we have deterministic rules, or hooks. While that Claude.md file is just advisory, hooks are absolute guardrails. They are scripts that run automatically at very specific points in Claude's workflow with zero exceptions. For example, you could set up a hook that automatically runs your linter after every single file edit, or, even better, a hook that completely blocks any writes to your database migrations folder. Between the advisory handbook and these deterministic hooks, you're establishing an incredibly solid, reliable environment.
Moving right along to Section 2, the art of concise configs, conquering the context window constraint.
So the crucial point here is that this is perhaps the most critical technical limitation you need to wrap your head around. Claude's context window fills up fast. Every single message, every file read, every command output, they all consume tokens. And as that window fills up during a long debugging session, the model's performance naturally degrades. Context is literally your most precious resource, which means you must be ruthless in your configuration files. You definitely want to include bash commands Claude couldn't possibly guess, project-specific quirks, and standard rules that differ from normal defaults. But crucially, you must exclude anything Claude can figure out just by reading the code itself. Do not bloat your config with detailed API documentation, just link to it instead. Exclude long tutorials or those massive file-by-file descriptions of your codebase. If you overload your Claude.md file with all of this extra noise, important rules will get lost in the shuffle, and Claude will literally start ignoring your actual instructions.
Which brings us to a golden rule of thumb for your config files. I want you to ask yourself for every single line, would removing this cause Claude to make mistakes? If the answer is no, cut it. Prune it regularly. If Claude is already doing something correctly without the explicit instruction, you don't need it taking up space in the file. Treat your config files exactly like production code. Keep them incredibly concise and optimized so you avoid crippling performance issues down the line.
All right, Section 3, automated verification checks, closing the trust but verify loop.
Here's the massive danger we face with AI agents. Claude stops working when the task simply looks done. If you don't build a verification loop, every single hidden mistake just sits there waiting for you to personally catch it, which completely defeats the purpose of having an autonomous agent in the first place, right? To solve this, we use a very concrete four-step workflow. 1, Claude implements the code. 2, Claude automatically runs a check. This could be a test suite, a build command, a linter, or even a visual screenshot comparison. 3, Claude reads that result directly in the conversation. 4, it iterates autonomously until passing. This closed-loop system is the magic key. It's the concrete evidence that lets you confidently step away from the keyboard and let the agent work completely unattended.
Now, what's really interesting is how simple it is to put this into practice just by slightly tweaking your prompt. Think about a standard, vague prompt. Implement a function that validates email addresses. There's no verification there, it's just hoping for the best. Compare that to a much stronger approach. Write a validate email function. Example test cases. User@example.com is true, invalid is false. Run the tests after implementing. By explicitly embedding those exact test criteria and demanding to Claude run the tests, you fundamentally upgrade the output. You aren't just asking for code anymore. You're dictating the verification criteria right up front. It's a total mindset shift.
And finally, Section 4, Independent Subagent Code Reviews, the adversarial review step.
Okay, we're introducing a bit of a plot twist in our workflow here. The agent that just wrote your code absolutely should not be the one grading it. The longer Claude works unattended, the more an independent, objective check matters. This is where sub-agents come in to save the day. They are specialized little assistants that your main Claude session can delegate to. First off, they run in their own separate context window. This means they can execute highly isolated specialized tasks, like deep diving into a complex bug or reviewing security vulnerabilities, while keeping your main session context perfectly clean. And most importantly for code review, they evaluate code diffs without the bias of the implementation history. They didn't write the code, so they don't have the mental baggage of the reasoning that produced it. They judge the result purely on its own terms to ensure your task requirements were actually met.
And this brilliantly illustrates the writer and reviewer pattern. Think of it as a parallel workflow to really scale your output. In session A, our writer agent implements a feature, let's say an API rate limiter. Meanwhile, in session B, our reviewer agent is prompted specifically to hunt for edge cases, race conditions, and inconsistencies in that exact implementation. The reviewer finds the gaps and feeds them directly back to the writer to fix. By isolating the agents like this, they trade objective, adversarial feedback to perfect the code, which yields incredibly high-quality, bulletproof results.
So, we've covered a lot of ground. We talked about setting a strong foundation with concise configs, automating your verification loops, and leveraging subagents for independent code reviews. But I want to leave you with this final, provocative question to chew on. If you can't verify the code with a test, a script, or a screenshot, should you even ship it? Seriously, think about it. Mastering an agentic coding environment doesn't mean trusting the AI blindly. Not at all. It means building a rigorous, automated system of constraints so the AI can safely do its absolute best work. Take these strategies, go prune those config files, demand automated tests, and start building smarter. Thanks for joining me for this explainer, and I'll see you in the next one.